Hi guys, welcome to the second session of aldehydes, ketones and carboxylic acids. Okay, so carboxylic acids I haven't included in the session because that would form a separate part of the chapter. Okay, so let's begin our session now. Okay, so in this particular session we are going to discuss a very important part, that is Cannizzaro reaction. So you already know that aldehydes and ketones react with bases, right? Very dilute bases, and there are a set of reactions. Out of them, two are very important. The first one is the aldol, and the next one is Cannizzaro reaction. Okay, so now let's start our session with knowing the basic details. So what exactly is Cannizzaro reaction? Cannizzaro reaction is given by those substrates wherein there is an absence of alpha hydrogen. I think in the section on aldol condensation, I have already given what exactly do you mean by alpha hydrogen. So you could just go back and revisit the video and know about it if you're still not clear about it. So just for a basic thing, alpha hydrogens, they are basically attached to the alpha carbon, and alpha carbon is basically the carbon atom which is adjacent to the functional group or the double bond. Okay, so now let's begin our session. What exactly it is? It is basically a self-oxidation reduction reaction. You normally call it as a disproportionation. Now in oxidation you get a salt of carboxylic acid, and in reduction you get a primary alcohol. Let's see how do you get that. So let's say if you have this aldehyde, so I'll write here CH double bond O. This is going to be the active part. Now this would undergo oxidation, right? So oxidation would happen over here, as a result of which you would be getting C double bond O, and it's going to be OH here, but since we are going to use a base, it is going to give you a carboxylic acid salt. Now let's see what would happen if you do the reduction. Reduction means addition of hydrogen. So addition would take place across the double bond, and that's how you will be getting the primary alcohol, that is CH2OH, right? So this is basic thing, very basic thing which you have already studied. Okay, and today we are revising, so that's great. Okay, so we already know it's basically an oxidation and reduction reaction. Okay, so let's see the general reaction which I've already told. So this is one aldehyde, this is another aldehyde. The most important criteria for these R group is that they should not have any alpha hydrogen. Common example is basically the formaldehyde and benzaldehyde, right? So we already know what exactly is formaldehyde. Formaldehyde is H, then you have a carbon, then you have another hydrogen, and then you have this O, right? And if it is going to be the phenyl group, right, you have this benzaldehyde, HCH double bond O. Okay, so this is basically the general reaction. So if you could see here, I have included the acid workup. In the case of acid workup, the base, in this case we are using a base, right? So you get a carboxylic acid salt. That salt is converted to carboxylic acid, right? So you have the primary alcohol and you have the carboxylic acid in front of you. Okay, so let's move on to the mechanism. So I do agree that mechanism is not included in the state board syllabus, but it's good to know about the mechanism because it is going to be definitely useful in the entrance exam. Most of you might be preparing for that, right? So let's begin with the mechanism. So as you already know, mechanism consists of two components. First is the substrate and then you have the reagent, right? So this is nothing but the substrate, right? So this substrate would be attacked by the base, which is nothing but OH minus. Now where would it attack? Obviously it would attack the carbonyl carbon because it's going to be electron deficient, right? So I have HCH. Now this bond would get polarized and this would become O minus, right? So it's going to become O minus over here, and then you would be getting an OH. Correct? Yes. So now what exactly is going to happen in this case? So in this case, you would be getting a very simple thing. So if you could see here, there is going to be base coming back again, right? So this base is going to abstract the OH minus, hydrogen from the OH minus. As a result of which, hydrogen would give the lone pair to the oxygen. So you would be getting H, and there would be C, there would be H here again, and it's going to have an O minus. Now there would be an O minus here again, right? O minus here again. Now, if you could see here, the byproduct is water, correct? Now what exactly happens? Water would come back, and then because of this water, protonation of this O minus would happen. So it would attack here, and then OH minus would be released. So you would be getting the next step. So it's going to be H, and you'll be having C. There is going to be an H here, and there is going to be an OH over here, right? And then you will be having this O minus over here, right? Now what exactly happens? Now this step is little bit crucial because this is nothing but the hydride transfer, which is going to create a very important thing, right? So basically you have another molecule of the formaldehyde, okay, another molecule of the formaldehyde, and you already know about the polarity. So if you know, this is nothing but partial negative and this is going to be the partial positive, right? So let's see what exactly is going to happen over here. So this oxygen with a negative charge would contain 3 lone pairs. So the lone pair would be utilized to form a bond. As a result of it, this hydrogen would be moving like a hydride. So what do you get over here? You would be getting something like this H, C, and there is again H. One H has already come here, and there is going to be this O minus oxyanion generated over here, and this product is going to be something like this H, and then you have C, and then you have a double bond O, and there would be an OH over here, right? Correct. Now in this step, what exactly is going to happen? Now the next step is pretty much simple. There would be a proton transfer that you could say, or you could just use water as a reagent to protonate this and then deprotonate this acid molecule by using a base, right? So I would do the direct proton transfer. So this proton is transferred. I would write O minus attacking this hydrogen, and as a result of which you get the carboxylic acid salt, which is nothing but H, C, double bond O, and then you have an O minus over here, and that's when you get CH3OH, right? So this is nothing but the mechanism of the Cannizzaro reaction. Now the most important and the crucial step is this step, right? And this step is called as the hydride transfer. Okay. So this is nothing but the hydride transfer. Okay, so this hydride transfer is going to give us the product. So this was about the mechanism of Cannizzaro reaction. Now let's move ahead with the rest of the session. Okay, so this is the detailed mechanism which has been displayed in front of the screen. It's pretty much self-explanatory, so you could go through it. Again, just remember the important hydride transfer that normally occurs over here. Okay. So we have the upcoming sessions which are going to be released very soon. Okay, so the first session is going to be exceptions for aldol and Cannizzaro reaction. There are certain substrates which do have alpha hydrogens but do not show aldol. There are certain substrates which do not have alpha hydrogen but show haloform reaction but not Cannizzaro reaction. So those are the very important parts that we will be discussing, and we'll be discussing very easy reactions, set of reactions, though they are very important, reactions of nitrogen nucleophile with carbonyl compound. Okay, certain exceptions as well. So this was all about this session on the second session on aldehydes, ketones and carboxylic acid. For any queries, you can email me in the email ID which is just given in the first slide and in the beginning of the video, right? So I hope you have enjoyed this session, and a very good luck for all of you for the upcoming exams, and thank you.